I hope you all had a refreshing lunch and are ready for the post-lunch session of day 6 of the ACM India Summer School. It is my great pleasure to welcome our esteemed speaker, Professor Nipun Batra, Associate Professor at the Department of Computer Science and Engineering, IIT Gandhinagar. Professor Batra is a distinguished researcher whose work lies at the intersection of scalable sensing and machine learning, with a strong focus on sustainability challenges, particularly in energy efficiency and air pollution. Professor Batra was recently honored with the ACM SIG Energy Rising Star Award 2025 and received the Excellence in Teaching Award from IIT Gandhinagar in 2024. Throughout his academic journey, including his PhD and postdoctoral research, he has received numerous prestigious awards and recognitions, highlighting his impactful contributions to both research and education. Today, he will be speaking on the topic LLMs for air quality, which also happens to be one of the exciting current research directions in his lab, exploring how large language models can contribute to addressing real world environmental issues. Please join me in giving a warm welcome to Professor Nipun Batra.
Thank you for the introduction. And I don't know if you noticed or not, this introduction is slightly different from the bio which is mentioned on my website. How did we go from the bio on my website to this introduction? ChatGPT. Like whenever you hear a lot of adjectives, you have to understand that it's ChatGPT like stuff. I'm not blaming. I'm just saying that the people are using ChatGPT like systems for various things. So in this piece of work, we wanted to study if we can leverage the power of LLMs for air quality. Now, think about this. LLMs, air quality, perhaps there is no relationship between these two. LLMs and energy, perhaps you can still understand because large language models run on data centers which consume a lot of energy. But what do you think is the relationship between LLMs and air quality? Okay, interesting. LLMs are language models. Language is inherently sequential in nature. Air quality is like other environment phenomena. It's also time series based. Okay. Any other thoughts? What is the relation between these two? Why are we studying this topic? Okay. So we'll start off by discussing the air pollution problem in India. I am sure all of you know about this, that it's a very big problem where about 1.6 million deaths are attributed to air pollution alone in India. So it's a leading cause of death in India. So if you remember a couple of days back, we saw a talk on different causes of death in which we had vehicular accidents, etc. Air pollution seems to be one of the most important ones, especially if you consider the entire North India plain. But that's the important part of the narrative. So North India is polluted. What about Gujarat? What about Gandhinagar, where you're currently sitting? Does it seem like a very clean place, very green place? Zero air pollution? Yes? Did any of you check the air quality of Gandhinagar today? Any guesses what it might be? 40, 50, something like that microgram per meter cube in terms of the PM 2.5 or the air quality index. I don't know the number, but I'm just guessing that. Now that number we might think is very good because the baselines are completely shocked. Like baselines, because of every time we hear about Delhi air pollution, the pollution capital of the world, etc., our baselines are very shocked. So it is unfortunately the case that in many of the other countries where the norms are very stringent and the environment is also more favorable, like India tends to be a very dusty country generally, just because of the way it's placed where it's located. So sometimes 2 microgram per meter cube, 3 microgram per meter cube is seen. It might be very hard to see it in cities in India because of various things which we've discussed. And the WHO recommends the limit should be about 10 microgram per meter. So maybe let's just figure out air quality right now. We do the search. It's using a different unit called air quality index, which is a composite index. It's a unitless quantity, which is a formula, let's say, which is based on the different pollutants like PM 2.5, PM 10, etc. And there are in Gift City, it shows 124, AQI 97, 87. All of them are green, but none of them is on the order of what the WHO recommends. So, and it will unfortunately lead to other diseases also, including heart disease, lung cancers, chronic respiratory diseases. So there are studies which say that PM 2.5 can reduce an average life expectancy of an Indian by about 5.3 years. It's a big number. So there is so much of research going on to increase the longevity, but this one factor itself in India reduces the life expectancy by about 5.5 years. So I'm going to, in this particular talk, discuss two kinds of work. The first one, I'm going to call it AQ Bench, which is we are going to look at the code generation capabilities of LLMs on structured air quality data. We'll come to it in a minute what structured means. The second is it's more similar to the way we use ChatGPT like systems currently, which is we just give it a prompt. We just give our systems a prompt to discuss about the various air quality questions at hand. So two kinds of problems. The first one would be structured data, which is code generation. We look at code generation. The second one would be we just give some natural language prompts. Before I do this, let's ask you a question. Which city in Punjab had the highest PM 2.5 concentration in 2024? Anyone? Sorry? Chandigarh. Okay, so again, people may think Chandigarh is one of the cleanest cities. So the answer is not Chandigarh, but think more. Ludhiana. Okay. Why? Who said Ludhiana? Okay. Why do you say Ludhiana? It has a lot of industrial setups, so it's likely to be more polluted. Any other guesses? I think a lot of people don't know about the cities in Punjab. And Chandigarh, Ludhiana, Ambala, perhaps you've exhausted the cities. So then we ask this question that can Google search and Claude, ChatGPT like systems answer this question for us? The question being, which city in Punjab had the highest PM 2.5 concentration in 2020? So the reason we are asking this question is that going forward, we will see increasingly people will rely on Google searches, on ChatGPT like systems, as opposed to, let's say, talking to a domain expert, as opposed to looking at a news channel. So we asked this question to Google Chat, and it says that Ludhiana has an AQI of 153 in 2024, making it the most polluted city. This is the AI overview which Google gives. Then we asked the same question to ChatGPT. One of the students asked this question, and they were also referred these different purifiers. I think they also got some advertisements. I did not get for some reason. So it says that Mulanpur, which is in Ludhiana district, it's not the Ludhiana city, but the Ludhiana district. And it also mentioned other significant PM 2.5 levels was the Mandi, Govindgarh, and Ludhiana city, which are 10th and 14th in India. We asked the same question to Claude. It perhaps referred to the same resource, which is maybe some news article or some press release, which again says Mulanpur. Does anyone know Mulanpur? Does it ring a bell? Nothing? I'm sure all of you watch IPL. Many of you watch IPL. No? Where is Punjab team playing some of the matches? So we looked at Google search, we looked at ChatGPT like systems. We're trying to understand that how can people currently answer this question? If given this question, what would they do? You could also go to these different dashboards like CPCB, Central Pollution Control Board, which is the national body which looks after the pollution, different kinds of pollution. So they have created these wonderful dashboards. Now, again, if I have to go to this dashboard and figure out, I'll have to perhaps first do a drop-down select to the state, to the city, and then give some time period. And for that time period, I'll get something. And I will perhaps have to go through each and every time period and then do the aggregation. Okay. So the dashboard is very good for certain kinds of things. But the kind of question I have asked, the dashboard will be a very difficult process to deal with. It won't be very easy to use the dashboard and get the specific answer until and unless this question has been pre-baked into the dashboard. Now, that is the problem. Can you pre-bake all of the kinds of questions into the dashboard? No. This is another dashboard from aqi.in. Again, you can see that it's showing this year-wise plot. 2020 to 2025, it's showing for the different cities, most polluted, least polluted, etc. And then there's another dashboard, IQ Air. So I would say that all of these are very useful in their own right, but the specific query which we had, that remains unanswered correctly. The correct answer, which we can get using the Central Pollution Control Board database, is Mandi Govinda. Now, a question to all of you. How did CPCB, how do we come to this right answer? I put this on the slides, but how do you know this is the right answer? Can you be a little louder? You have to verify. But so my question was slightly basic. So what does CPCB give you? Yes, it gives the credibility, but it also gives, the question was even basic. So CPCB gives you the data. Where does the data come from? Sensors. Does anyone know the cost of these sensors? Have you seen any of these sensors? So CPCB, these big sensors, often called BAMs, these are sometimes on the order of several crores. So therefore, they are not installed each and every place. There are other sensors which are cheaper, which you can get on the range of 30 to 40 to 50,000, but they're, as expected, not so accurate. So, but we'll use them, these particular sensors, as the true sensors, as the ground truth. As of today, I think they're on the order of about 600, 700 sensors across India. There are surveys, there are studies which suggest this number should be around 4,000, but currently it's 700. So this also prompts another direction of work, which I believe Vinayak and Zeel showed. Can we use active learning to decide where to place the next set of sensors? So that's a different problem which the lab is tackling. And coming back to this problem, we can use the CPCB data and answer this kind of question. But in order to do that, we will first need to download the CPCB data from their website and and then I would run some Python or some SQL code on that database to try and get the right answer. So can all of you do this? All of you, I believe, are enough proficient in Python and enough proficient in the usage of Gen AI tools that given this specific question, you can prompt to get your answer. But think of a broader audience. Can everyone in India answer this question? Does everyone have a SQL or Python skills? Does everyone have the skills to scrape data, download data? To the policymakers or the people who really have the power to change things, unlike us who can just run some code and get some numbers, can they run Python codes? They will perhaps ask you to create some specific dashboards, but then you have another new question. So you can't create a new dashboard with a new answer each and every time. So therefore, we wanted to show this kind of bottleneck in the current approaches. So this is how the CPCB data might look like. There are different portals. This specific one allows you to choose between the kind of data, the state. The station means the sensor name. This one is the Golden Temple, Amritsar, Punjab Pollution Control Board. The frequency at which you want the data, 1 day, 15-minute, etc. So it does the aggregation itself. And the city is naturally, in this case, Amritsar. So you can download this data in the form of some CSV-like format. And so then you'll get this screen to download the year-wise data. And then the data might look something like this. For this particular sensor, you will get a time series with these different pollutants, PM2.5, PM10, NO, NO2, NOx, NH3, SO2, CO, etc., with respective units. And you get these time series data. In this case, you're getting a single reading a day because we chose that frequency. So now once you have this table, once you have this database, now is it an easy problem for you? You have to figure out that which station, which city in Punjab had the highest pollution. So you have to look at each and every city. You have to look at all the sensors present in the city and doing some spatial aggregation around that and some temporal aggregation. So you could have written some Python code like this. You get the DF, pandas data frame. You group by city. So I believe all of you know the difference group, split, combine these kind of operations in SQL as well as in Python pandas. You group by city, look at an attribute, find out the mean, and then sort and then give the highest value. So this is a 3-4 liner code that you can write to get the city in Punjab, which has the highest PM 2.5 for the year 2023. So what we said was that we want to now study if LLMs can do this for you. So given a natural language query, can the LLM generate the Python code, which when executed on this database, on this CSV file, can give you the right answer? The advantage of this approach is that we don't really have to worry about what next kind of question can be asked, and it should be generally adaptive to different kinds of questions, detailed, which require joins across multiple tables. So that was the whole approach behind this. But importantly, we said that before we deploy such systems in the wild, let's see if we can benchmark. Let me first show you what the system deployed might look like. So this is a Hugging Face app which a lab created called Vayu Buddy. So you'd ask some question like this. So your question is, which month has the average PM 2.5, highest average PM 2.5 in 2023 for Mumbai? It's a natural language query, which when executed is going to generate this code. So this query goes in, the LLM, in this case Llama 3 or Mixtral or Gemma or Gemini Pro will execute and generate this code, which will then get executed on our database to return the answer that the month with the highest average PM 2.5 is February. It's returning 2 in this case. And we can also try out different prompts. Sometimes it fails because I think it's a little out of date also. So it will be a nice exercise, not right away. After the session, you can also give in some custom questions. So figure out if you can break the system, if you can get some good answers, some weird answers. Which state has the highest average PM 2.5? Again, the generated code is, we look at it. We read this file, which contains the states, etc., the name of the states, etc. We are also looking at some, like in this case, I think the code is specifically handling Ladakh, J&K. The main operation is this, that you do a group by on the state of the attribute PM 2.5, and then you figure out the aggregation over the mean, standard deviation, and the count. So you can also see that this code is not perfect because it's repeating this line. And then you figure out the answer, and it says Delhi with average PM 2.5 is the state with the highest PM 2.5. Now, if you show this answer to political parties, they will either embrace you or they will kill you, because here I'm writing Delhi as a state. That's the whole, lot of fight about Delhi as a state versus union territory with whatever status it has. But all those things apart, I hope you broadly get a sense of what we are trying to do in this project. Natural language queries, which are then given to a LLM, which we give it some basic things, which is known as system prompt. It generates the code which executes on the data, CPCB data, and then we get this kind of an answer. Let's see if we can also get a plotting question to work. This is running slowly because it's running on Hugging Face and we are not running any on any GPU. So you saw this, you can now see that there is some specific error which is occurring, unterminated string literal. This is some matplotlib error which is occurring. So again, I think in the next version, we should perhaps have a try catch exception, etc., which returns an error more gracefully. But sometimes back it works. So I think something has changed. The LLM is perhaps not giving a good answer now. Let's try another time with a different query. Monthly average PM 2.5 for the year 2023. So in the meantime, you're getting a sense of, okay, we've got the plot, which is showing this. This is the pollution across the different months. PM 2.5 in Gujarat for 2023. This is the India limit, and this is the WHO guideline. So you can see that for some part of the year, it's above the India limits also. It's more polluted. So I hope you get a broad sense of what we're trying to do in the project. We want to start with natural language queries, use different LLMs, generate code, execute, and show the output. Hopefully, the different stakeholders can benefit a lot from this, and they can also ask very sophisticated questions also. When it rained last time, what was the reduction in PM 2.5 in the North Indian states? Something like that. What is the effect of, let's say, high winds on reducing pollution? Something like that. Or on specific dates, on, let's say, New Year's Eve, how much was the increase in pollution, assuming that there was a lot of crackers, etc. So these questions can be answered. These are the kinds of questions which the policymakers, which the governments, the organizations, the decision makers, they want to answer. So in order to build, so this is the system built, but we also want to have a benchmark around this. Are we doing this correctly or not? In this case, you perhaps don't know, you're trusting me, but you would have to actually go through the code and check whether it's correct or not. So the first part is we're looking at AQ Bench, which is the benchmark containing about 10,000 questions, air pollution related queries with the ground truth Python code. Given a natural language query, we look at what the true code should have been for answering that query, and then our system will generate some Python code. So we have looked at several important data sets for this. One is the tabular data from CPCB, which is pollution for station, for city, for time. We have NCAP program, which is National Clean Air Program. So the government has these different initiatives, like they have Clean Ganga campaign, and then they have this National Clean Air Program. They have different programs. They're trying to allot the money. So again, as a policymaker, I would be concerned if I'm putting in 1,000 crores, is my particular city reducing pollution or not? There was a funny article sometime back, funny and very unfortunate article also. So a lot of the funding in NCAP is just getting dusted away. Does anyone understand what this meant? Dusted away. So a lot of the municipalities, without having proper means to reduce the pollution, they are just working at de-dusting solutions, just spraying water on the streets, and that is all they're doing. A lot of money is getting wasted there. So this was some report, you can look that up. And then we're also looking at state demographic data. So this contains your population, your area, etc. So this is again to see if the distribution of census is equitable or not, is the distribution across rural and urban comparable or not. So those kinds of questions we want to answer. So the CPCB data would look something like this. You would have timestamp station, the pollutants, the lat long, and the state. So we have made this, we have downloaded this and organized this as a repository in a CSV format, comma separated values, from the year 2017 to 2024. So therefore, whenever you hear about knowledge cutoff date, for LLMs, we have different knowledge cutoff date. For us, the knowledge cutoff date for the LLMs, we don't care about that much, but this is the data cutoff date. The tabular data cutoff date for us is 2024 December. And importantly, we need to know the schema of the data set, of the database. So we have the timestamp in date time format. Station is an object or a string. PM 2.5, PM10 are floats. We don't really care about the address. We care more about the latitude, longitude, and the state. And now coming to the National Clean Air Program. So we can see that there are some number of cities, around 131 cities, which come under this program. So these are the cities where the pollution is above a certain level, where the annual pollution is above a certain level. And the government will put different funds to try and see if this pollution can be reduced. So folks, I don't want to be going this route, but do you want me to take surprise quizzes with the marks? No? So try and make most of the summer school. That's my honest advice. Your work on your laptops, I think you could also do later also. Try and make the best. If it's still not useful, it's fine. But don't miss out on the opportunity. So coming back, around 10,000 crore released to 131 cities from these financial years. And this was mainly to also support research, monitoring, capacity building, which means train the researchers, train the air quality experts, train the state pollution control boards, etc., to do whatever is needed to reduce air pollution. So naturally, whenever money is involved, we also want to see some outcomes. That is why we included this in our data set. This contains the different cities across the different states and the amount released during financial year. What is the unit for the amount? 200 crores. Okay. Similarly, we have the demographic data, which contains the population density as well as the districts, etc. So again, these are the geographies. This is the unit in which a lot of administration is done. The decisions have to be taken by the local body. So therefore, we looked at this census data and we had something like this: name of the state, the population of the state, the area, and whether it's a state or a union territory, etc. So once we have these different schemas, we define 7 categories of questions pertaining to air quality. Any guesses to what those categories might be? What kind of questions would it be pertinent to ask about air quality? Sorry? About this mic.
One may be about the release, that how much is my government funding or what type.
About the release of the pollutant?
Release of the money.
Release of money, okay. So I would say that this kind of a question is cutting across these different tables. Yes, one kind of a question about the metadata, about the auxiliary data. That would be one kind of question. What could be other kinds of questions? Think of some questions you may want to ask. So in the morning session also, like Udit showed certain things about Surat city, right? So think of the same thing. That was from a flood perspective. Think of the same thing from a air quality perspective. I don't know if you've seen hoardings here or not. There are a couple of hoardings in Gandhinagar also. But if you go to Delhi, Gurgaon, Noida, you'll see a lot more hoardings about the air quality of that particular society being very good. So the real estate prices are going to be controlled by these factors. So then what are the kinds of questions you may want to ask? Impact on your health. Okay, so maybe that is one. Change over time. Okay, the progression over time. Okay. So one particular question is change over time would be more like temporal trends. How is the air quality changing over time, over the seasons? So therefore, we created these different kinds of categories. Let me first show you the spatial aggregation. Which station in Delhi had the highest PM 2.5 in January 2022? So you have multiple sensors in Delhi, around 40. So what we're asking is, amongst these 40, which are spatially distributed, which of them are the highest PM 2.5? In other words, we fix the time. You're only asking the question over the spatial dimension. So this should give you a hint. If one question category is spatial, what could be another question category? Temporal. The temporal might be, how did the PM 2.5 vary across 2021 in Lucknow? So you fix space, vary time. You also want to see how does it vary across, let's say, different seasons, crop sowing seasons, which was also discussed in the previous thing, across the different, let's say, important events of the year. So two categories we've got. One is spatial, one is temporal. What could be the third one? Can you combine these two? Spatio-temporal. So spatio-temporal is which state had this. So let's say which across space you have to do some aggregation, across time you have to do some aggregation. So in this aggregation is done across multiple times multiple time windows in 2022 and across different stations, across different space. We are also doing some aggregation. So therefore, the aggregation is across time and geography. This is the third kind of question. The fourth would be some specific patterns. This would be, let's say, how many times did Mumbai violate the PM 2.5 limits, Indian limits or WHO limits? Again, this comes from policymakers. They want to, let's say, put some money in these cities or put some penalties in them. Another kind of question is, now we start looking at the question which are combining the different data sources. Population. Which state has the fewest stations relative to its population? So ideally, you want some equal coverage across. So until unless we have data, we can't really understand the air quality of a place. So therefore, you don't want a large quantity of a lot of population without having access to any data or having any air quality monitor close to them. In that case, we can't really make any prediction for them, any improvement for them, because we don't have the data. So then we are looking at these auxiliary data sources. One is population, the other is area. So you also, if you look at the air quality monitors, what do you observe? These are the locations. What do you observe? Yes, so you can say J&K, as well as in some states in the north, it's very sparse. Here it's very sparse, very sparse, very sparse. If you take out Delhi, Mumbai, and certain other metro cities, it's sparse. But again, there are lives at stake. Does it mean that the life of a person in an urban city is more important than the life of a person in a rural city? If we were to assume that sensing means more importance, no, probably not. Definitely not. So therefore, these are the kinds of questions. Again, we want to enable the policymakers to answer. Which of them they want to look at some area statistics while trying to answer such questions. And very importantly, when there is a program, there is funding associated with it, how will that funding be used? Is it being used effectively or not? Which state, so this is one kind of a question, which state has the lowest PM 2.5 level, which is NCAP funded? The other would be proportional to the NCAP funding, which state reduced its PM 2.5 the most? Right? Which is something like, for every 1 crore rupees spent, which state was able to reduce its PM 2.5 the most? That is a very powerful statement. That would be perhaps leading to some actions which were taken by them, which the other states can emulate. So these are the kinds of questions which we want the policymakers, the government, the news agencies to be asking, and we want to be able to give them such answers. So therefore, in order to, we have created these 7 question categories. Now, we also wanted to create, so we said that about 10,000 questions. So do you think we'll manually write 10,000 questions? What could we do? Little louder. You could use another LLM to generate the questions. Then you'll have to have another human verifier to verify those. That's a valid approach. Could you help that LLM generate questions in a slightly better way? LLMs, one problem with the LLMs you might have seen is they're very unstructured. By default, they're unstructured. They will not follow any specific advice until unless you have very clearly instructed. They'll also be very verbose. So therefore, what we said was we will create some question templates. Like which, and then there's this tag, which location has stats method pollutant in year, and some instantiations of these. Which station has highest, stats is highest, method is mean, pollutant is PM 2.5 in year 2021. Now you can change the location from city to state to state to station. Station, city, state. Statistics could be, let's say, highest, second highest, lowest, second lowest. The method could be mean, median, something like that, any kind of aggregation. The pollutant, of course, fixed, PM 2.5, PM 10, year you could also change. Now, just by creating this template, I can instantiate this template as many times as I want, as much as the combinations I have. So this gives me a rich method to enhance my data set size without having to worry about the fact whether the LLM has hallucinated or not, whether it's created some stupid questions or not. Now I'm sure that it's a simple nested for loop, which I have to follow. Then importantly, we still have to write the ground truth. Now the ground truth is, now do I write ground truth for 10,000 questions? Is that feasible? No. Again, once we have a template, can we create a templated code whose arguments would be location, stats, method, pollutant, year, and the answer would be generated using the code? That's the method, that's the whole insight. So we'd create this code template, which would be like having these arguments, year, city, column, limit, etc. And then we will have this specific instance depending on the arguments. So it would be like, now city would be replaced by Mumbai, column pollutant would be replaced by PM 2.5, the limit is replaced by the Indian limit, 60 microgram per meter cube, so on. So now for each of such question, we have a true code instance. Now when we're talking about the LLM generating code and as benchmarking, do you think we compare the generated code and the code instance? Is that how we'll go about it? Or something else? We can check the output. Because, why do we want to do that? Yeah, because we can get the same answer through different code. So we also ended up sampling the questions instead of using each and every question, because that would have been a large database. So we had generated about 27,000 questions using the template. We then sampled around 10,000 of them. Sampled is just pick up 10,000 out of 27,000. And we also ensured that there was enough coverage across each of the templates. So I believe we had 80 odd such templates. Is that true? We had about 80 odd such templates. And for each of them, then you can figure out how many, about 120 odd instances per each. Importantly, we also noted that so this is the template which I have given. But another user might not give the question in this format. They may choose to ask slightly differently. Now, how do I handle that? Let's say someone else may say, n year, what is the maximum, what location has something else, right? So I can change the whole order. Or I can ask a very, very long sentence, which is going to mean this. Yeah. So you could use LLMs to convert queries into existing formats. That is something you could do. Or what we are also doing is we are doing the reverse. We're actually asking the LLMs to also perturb these queries so that we get more diversity in our training data set. So we can take such queries. Let's say this is the original question. Which station has the second lowest average PM10 in July 22? We can also ask the LLMs to generate more variants of this question, which is the exact same meaning, but it's just another variant. Determine the station with the second lowest average PM10 reading for July 2020. And more, you can do more. This is just showing the procedure, but you could just do this even more. So overall, we had about 82 templates and about 27,000 instances. We divided them into different categories: spatial, temporal, spatiotemporal, specific patterns, which is, let's say, how many years are we missing out? Are we above the limits? And then these are the auxiliary data sets: population, area, and funding. So we had these different kinds of categories of questions and the splits we wanted to show. Importantly, we also mentioned the system prompt. Does anyone know what a system prompt is? Sorry? Yeah, you want to tell ChatGPT-like systems how to answer. So have you seen that if you or your friend ask the same question, you get very different answers? Because over time, there has been some persona built up. Right? And there are also methods like ChatGPT-like systems allow you to specify that persona, or this allow you to specify something equivalent of a system prompt, etc. Like for example, when I write such things, I would tell ChatGPT, do not generate emojis, because anyway, when it generates, I had to ask it again to remove the emojis. I would also ask that I have been faculty teaching machine learning for the previous 8, 9 years, something like that, so that it doesn't get me into the basics of machine learning, which I probably, let's say, no, I don't want to. And I may also ask it to cut to the chase, do not give me very verbose answers. So those are some of the kinds of questions, and also maybe tell me that I might tell a little bit about my background. So that may help it to answer my questions better. Similarly, now when we want to answer such code generation questions, we do have to give the schema, because otherwise code generation I have no idea, right? So therefore, for this code generation through this LLM, we give the schema for the different data sets, and we also give some example usages. So we say that you have to answer this with this specific format only. So this also helps us while we are evaluating. If we get all the functions in a common format, in a single format, our evaluation will only become easier. So overall, to define the flow, we'll start with the question categories. We saw 7 question categories. We created these templates. We created the instances. We sampled about 10,000 from them. We paraphrased some questions to have enough language variation. And we have also made this available on Hugging Face. So now when we want to do the evaluation, we have the ground truth database and the true code. We will ask the LLM to generate the code, which we know the output from our true function and the output from the generated code. We can then do this comparison between them and then figure out whether it's correct or wrong. Should we stop here? We're not the talk in this work. Should we stop at this point when we have figured out whether it's correct or wrong? Should we do something else? Okay, one is a feedback mechanism, right? So let's see. What would you like more? If your teacher gave you a 5 and 10 and just gave you 5 and 10. Secondly, gave you a 5 and 10 and told you where the 5 marks were lost. Which is helpful, the latter one. So yes, so we need to figure out that when we are wrong, why we were wrong. So this will potentially help us improve the benchmarks going forward, improve the LLMs going forward, which is this error analysis. We want to do this. So we're looking at a few metrics. They may seem scary to hear the names. Exec at 1. This is the proportion of generated code which runs without errors in the first time. So this also gives you a sense that we're not running the code once, we're running it multiple times, as you would expect. With LLMs, you may get different answers each time you run. And this pass at K. So by the way, this exec is just execution, not correctness. Okay, this is just execution, whether it executes or not. Pass at K is, if you run the LLM K times, how many times does it give you the right answer? And then we're also looking at the syntactic errors. When some syntax error is made, then whether it leads to a compilation error or not. So therefore, we define the error rate as the number of times some syntax error occurs. This is best shown via some examples I'll show in a minute. We're looking at these different code generation LLMs. These are specific to generating code, and some general purpose LLMs like Llama 3.2 1 billion, 3.2 3 billion, and then Mistral 7B Instruct version 0.3. So you can see that we had a variety of these models. None of them are super large, but all of them are like, some of them are these specific ones and some of them are more general. So in order to just quickly go through some of the results, these are showing the different scores. Pass at 1, pass at 2, exec at 1. You can see that if you compare these code gen LLMs, in this case Quen 2.5, it is performing better than this Llama 3.2. Both of them have 3 billion parameters. So perhaps this is suggesting that the specific variants will often give you better than the general purpose variants given the same size. It's not always true, but in this case, we can see this learning. And we found out that Quen 3, 32 billion parameter, as expected, the biggest model in our suite, performs the others, and Quen 2.5 coder 14B was also comparable. This is another interesting kind of a visualization, sometimes called radar plot. So you look at these different metrics. These are the different kinds of questions which we had: spatial, temporal, area-based, funding question, etc. So we have these categories. And now we're trying to see if there are certain models which do well across some categories and very bad across some other. So what we can see that is this Quen 2.5 coder 14B, which is shown in orange, 12 Quen 2.5 coder 14B. It is sometimes better than in this Quen 3 32B, which is shown in blue. And this pass at one metric despite having lesser number of parameters. Okay? So therefore, it's not always the case that bigger models will do better than the smaller models. Sometimes it's the training given to them. Sometimes it's some other metrics given to them, some other kinds of post-training given to them. Importantly, you have to do this benchmark exercise to understand where the capabilities currently are, like what is the state. Okay, this one is showing the orange one, and you can also see the blue one. And this is the spatial one. So you can see that it's better. This one is slightly better along the spatial axis as compared to the blue one. So again, there are a lot of numbers. I will skip the learnings here, but I think more importantly, we also need to now understand where are the LLMs currently failing. What do you think? Where do the LLMs fail in the code gen? Where do they fail for you when you write Python code for your assignments when you have 5 minutes left to go before the deadline? Okay, understanding the context. I mean, in terms of the generated code, let's assume it's generated the code. Where is it wrong? Sometimes it's syntax error. So it cannot execute its own code. Sometimes with agentic capabilities now it is able to. You can execute, but in general. Yes, sometimes there are data types error. Sometimes you will see variables which do not exist have been referred to. How many times does that happen? How many times does it happen that papers which do not exist are there in your report, and you go to the presentation and what happened? Like your advisor, you're hoping that your teacher or the advisor does not see your mistake at the last minute. So we'll be looking at syntactic errors only for now, which is when the code contains some error which causes the compilation error. So we look at these different kinds of error: import, name, column selection, etc. Like, what is the problem in this? It created this variable PM 2.5 underscore state. You can't use dot or point in variable names. So it thought very well, PM 2.5, and then it created the variable. So this is a very small kind of a mistake, but this happens. So this was the question. Determine the city that recorded the third greatest average PM 2.5. This is a very weird third greatest average question. But you can see that the variable name. Okay, so in this case, what is the issue? This city PM 2.5 is used in the variable. It's not a valid. Okay, then the question was identify the station that recorded the minimum 2.5 on this particular date. So it's trying to access this data PM 2.5, but this PM 2.5 is not an attribute of this. Sometimes it will use undefined functions, etc. So in this case, it's trying to do data of timestamp equal to something of something, but I believe data does not exist at this point. and from pandas import PD. Right? So generally, I think the what we generally write is import pandas as PD or import pandas as PD, but from pandas import PD. So these are some kinds of error. I hope that many of these are easily fixable. This one is an interesting one. So here, I also feel that one of the harder questions would be where you have to do some merging across multiple tables or joins. So it is giving an on join, so join on state, but it's also giving a left join on latitude. So the error is that it should be, you can only pass either on or left on or right on, but not a combination. So you could either do a left join or a right join, and then maybe one or two other joins, but you could not do all, you cannot pass all the arguments. So importantly, the smaller models, which are also very generic, they show very weak Python syntax understanding, and that's where we had a lot of errors. But the more powerful ones, specifically the code generation ones, like Qwen 2.5 Coder, they had a much better understanding of Python syntax. So what we hope is that this can empower different policy analysts, NGOs, researchers who do not have the capacity to build a new dashboard every single day, or to write very complex SQL or Python queries. They can do what they importantly wanted to do, which is to generate insights from the data. That is the bread and butter. And importantly, we believe such technologies can help break the technical barriers so that more people who are domain experts can also leverage such technology. So in the future, we felt that we should not be limited to only CPCB-like datasets, but also satellite data. You had a couple of interesting talks in the morning. So because there are a lot of places where we still do not have any sensors. So can we use some satellite-derived estimates for those places? We only have these sensors, 580 odd sensors in India currently, 600 odd, right? And the number of cities you would know is a much larger number. I also talked about the fact that there is a current knowledge cutoff date, which is the last time till I downloaded the CPCB data. Perhaps we could build, let's say, a tool call, which is a function call or a tool call, which fetches any data beyond that, and then it can run these queries. So that's what we thought we should be able to do. We also want it to be running on smaller devices, so that on phones also, as opposed to being running only on powerful servers. So currently, the best models which we have will not be very trivial to port to smaller devices. And it should not just be about the tabular data, but also text data, tabular geographic data, because there are other kinds of questions also. So which brings us to the next part of the talk, and I can take some questions before that. Yeah, so multimodal reasoning would be, so let's think of some other kinds of questions which you may want to answer. Like what we typically might do now by ChatGPT-like systems. Take a photo. Is it safe to live here or not? That's one kind of a question. The other kind of questions you may also want to ask is geographic data, for instance. So let's say if I give you some elevation data, which is digital elevation maps, can you then fuse them with the pollution data? So can you also, let's say, look at the wind data? Currently, we are not looking at the wind data. Those are much more sophisticated data sources. Could we look at the simulation data? So in the morning we talked about the gridded data. We also talked about WRF-like systems. So could we leverage those or not? So that would enable you to answer more powerful questions. Think of an overall system. Let's say that you are someone sitting in the parliament in Delhi who wants to solve the air pollution problem. Now you'll ask is, what do I probe? So by probe, I'll mean what are the control points? So what do you think are the control points to reduce pollution in India? One is power plants. What could be the others? Construction. Okay, what could be others? Vehicles, like we had odd even in Delhi. What could be some other control points? Industrial emissions. So let's say that you have about 20, 30 such control points. Each of them is some, let's say, slider. and each of them has some economic impacts also and some livelihood impacts also. So what you want to do is looking at the metrology of India, as well as these different indicators. Can you tweak these and then some simulations runs? Eventually you'll get a sense of what parameter knob do I tweak so that my pollution can be reduced by X%. Currently, we can't answer that very well. We do have these forward simulations, which are like, as was also mentioned in the earlier talk. But again, those are only accessible by experts. It would be very, very hard even for someone like me to run this. There was another question. Yes.
So, sir, when you're using an LLM to paraphrase the question, then how are you verifying that the paraphrase question is correct? Because
human in the loop. So we do human in the loop verification to ensure that those questions still remain contextual.
So that would be taking a lot of time.
Yeah. So this is a very hard amount of work. Like, this is not trivial to do. It takes several months to do this benchmarking exercise.
And also the Vayu Buddy bot that you showed, what if we put irrelevant question, nothing related to air?
Yeah. So currently it might fail. Like, I don't know if some of you have seen this joke or not. Like, on various help websites, like people, like now every company is creating this chatbot. You can talk to them. Someone asked them if they could give some JavaScript code, and it returned with them the JavaScript code with some airline company. So I think there have to be checks and bounds, and it should. So I think the simplest case would be take the query and first do binary classification. Should I answer this or not? And within the scope or not? If not within the scope, directly answer this is not within my scope. Currently, we're not doing that, but people can make pull requests.
So did you tried putting something on the system prompt so that it would deny those requests?
We are a little worried about changing the system prompt, because then I think it changes everything. Sometimes we may, if we go this route, I think I don't know if some of you have read through, I don't know how correct those were, the leaked system prompt for some of the popular services these days, like Claude, etc. If you go through them, some of them even end up going that, you really have to help the user, they have a gun on their head, things like that, right? So we didn't really want to go that route. But I think one is the system prompt route. The other is to actually first do another layer of classification. Let's just do a classification. Relevant question, irrelevant question. So in fact, think of this whole, when I mentioned this whole broad encompassing question, we also have to think about, should I send this question to a code generation LLM, or should I send this to a RAG, or should I send this to just a generic LLM? Should I send this to a human? Should I deny to answer the question? So you'll see this paradigm across multiple of the talks going forward also, I think. Sorry? Any specific reasons for the Quinn model? I think they were working well across different benchmarks, but I think the students can answer that better. Okay, so the code generation part was obvious, but I think they're also mentioning that because perhaps more performant open source models, not open source, open weight models. Okay, other questions?
Sir, can you go to the slide 47? Yes, so evaluating based on output. So are you comparing the code, syntax, or result of after executing the code?
We execute the code and then we compare the answer, because the LLM might have used some different strategy to generate that code. It might not have been the same. Like, there are multiple ways in which you can do a group by also. Different orderings. You could completely skip a group by and just do a for loop for that, etc. Okay, so I'll go to the second part of the talk. which is similar to how we currently do search, which is we directly ask ChatGPT our questions, right? We don't really tell it. Very rarely do we give it some table and then ask some questions. We just directly ask ChatGPT questions. The reason why we wanted to explore this possibility is that, like, many of you are now, okay, how many of you are using ChatGPT more than Google? Anyone using Google more than ChatGPT? So Ujjwal and I can understand, both of us are slightly older than you, but the younger people, why are you still using Google more? Okay, not to say this not bad. I meant more traditional search versus more ChatGPT-like search. I think generally the trend has been to go there because you can write whatever way you want and you'll directly get the answers, as opposed to having to go through a bunch of links, read through them. Right? That's the hard yards, which people now don't want to do. Any other reason you have? Okay. So his answer is that when he asks ChatGPT, he often does not get the answer right away. He's been given something which goes round and round, and then there's an endless conversation, specifically with code. It gives you arguments which don't exist, and then you end up spending 2 hours for something which you could have done in 5 minutes if you directly did a Google search. So, you wanted to say something?
I mean, my way of understanding is that when I want to have some factual information searching, I want to rely on multiple sites and then verify that.
Okay.
When it goes with conversational part, he may lead me to some other factual.
Okay. So that's an important bit, that what is factual, what is not factual, are those websites correct or not, is the ground truth correct or not, how much of this is hallucination or not. So these are all the kind of questions which I think all of us are going to deal with going forward. But I can still largely say that for a lot of our questions these days, we are now indeed approaching LLMs, including me. So we wanted to check if there are hidden biases in reporting air quality. If I had to ask something about it, like there have been a lot of biases about machine learning in general, like let's say white skin versus dark skin. There have been biases. So there have also been biases between, let's say, the West and the East. Like, we wanted to look at that. So we'll take one example. We asked this question to ChatGPT. Estimate the average PM 2.5 for the city Begusarai. Does anyone know where this city is? Begusarai. Bihar, I don't know. Prince, where is this? Where is the city? Bihar. Okay. So it showed 64.8. ChatGPT gave the answer 64.8, whereas the ground truth is 148. For Delhi, the ChatGPT gave an answer 108, whereas the ground truth was 102. So what it shows is that Begusarai was underpredicted. ChatGPT underpredicted its pollution. Delhi, it's overpredicted. Do you see some patterns and bias here? Why do you think this exists? One could be less trained, but what is the general narrative about air pollution in India? Delhi is polluted, Delhi is this, Delhi is that. Everywhere else you don't care about. Delhi also have the political center. It is also the place where you have the maximum number of sensors. So naturally, there are a lot of talk about that. So we want to notice such inconsistencies so that these biases don't get propagated. And when we look at these biases, we will often see that these biases can be spatial in nature, like across space, can be seasonal, can LLMs? Yes. The ground, good question. So the ground truth is again from CPCB. That is from the sensor data. No, so we did the aggregation in time. So this is asked for the year 2023. We expect ChatGPT to have done the aggregation or know the aggregate value. And here we have done the aggregation ourselves through code. That's a good point. We cannot expect ChatGPT to be correct, but we should not also expect, or we should hope that ChatGPT, like systems, like not singling on ChatGPT, they also don't exhibit and propagate biases. That is important. If you don't know, say I don't know. But how often do we see the answer I don't know? Yes, so it's an inherent limitation. But unfortunately, the way the currently such systems are being used, very often they will be just looked as facts. In a very specific audience sitting here, perhaps you may know this, but the large populace will probably just accept this as true. This is one very specific example. Going forward, we'll see more examples and see that how such biases are propagated, are present in the data, present in the predictions. So we look at such questions. The first question we look at is, do LLMs broadly understand the plausible ranges of PM 2.5? Like, I would be very, very angry if LLMs said that your PM 2.5 is minus 10 microgram per meter cube. It does not do that. Fortunately, we'll see. Do they predict the concentration across the different cities? In India, we're primarily limiting the geographical limits to Indian cities for this. Very importantly, does the LLM prediction correlate with actual PM 2.5 or not? Do they show seasonal variations? So, okay, so let me ask this question. Why are winters more polluted than summers? Okay.
Primarily due to fog, cold weather.
Yes, but why does fog happen only in winters and not in summers?
Cold. It's cold.
But how does cold increase the pollution?
It affects the visibility.
Yes, the visibility is a side effect, but how does it affect the pollution?
Hot air circulates more.
Sorry?
Hot air circulates more than cooler air.
Yeah. So have you felt that in winters the air is dense compared to the summers? So think of this as, if this is the room, this is the, let's say if we have some, I don't know, 10 kg equivalent of pollution here, something like that. Whatever units, 10 kg equivalent of pollution. Now, if you were to reduce the height of this room by 3 meters, will the pollution look to be more? Because the density of the pollution has increased. So that is exactly what happens in winters. A planetary boundary, some very specific term called planetary boundary layer height, that reduces in winters, which ends up giving you more pollution, even if the emissions are the same. So we wanted to check if LLMs have the understanding that there is a seasonal variation in pollution or not. Do they exhibit any geographic, socioeconomic biases? This is particularly important because think of this as, again, if policymakers, if people with power end up using LLMs to figure out what they should do with the fund, and the LLMs will say, put everything in Delhi. Is that okay? No. So we want to check that. Are the cities, lower tier cities, are they underrepresented or not? Very importantly, so when you entered Gandhinagar, you must have also seen the green capital of India, something like that. Does being green mean lesser pollution? How many think yes? More green means lesser pollution. How many think no? Why? Anyone? Sorry? Okay, it's very hard to hear, but yeah, so thinking about renewable energy, etc. So green generally means the tree cover, etc. Right? You could have a lot of tree cover, but you could still have a lot of emission. So pollution generally means emission, like it's tied to emissions, whereas green is generally tied to trees. While, of course, having more trees will help you with various kinds of pollution and other problems, but if you're not reducing the emissions, even the trees can't do beyond a certain limit. And then there are very complicated compounds which will be very hard to dispose of. So therefore, to solve the pollution problem, the best way is to reduce the emissions. So let's look at some of these questions. Now the models that we use here are slightly different, and this depends on the model availability, etc. So we are looking at Gemma Llama, Gemma bigger variant 27B. IT here means instruction tuned. And the 70 billion Llama 3.3. And we had used them by downloading them from Hugging Face Transformers library. We used CPCB data, which we were previously also using as a ground truth data. We also did aggregation across city, across different timestamps. So we didn't want to ask very specific question. What is the air pollution on June 7th, 2024? We didn't want to answer those kinds of questions. We want to understand whether the broad trends are known or not by the LLM. So therefore, we were doing aggregation across space and time, across multiple stations in a city, across time to a monthly or a yearly resolution, something like that. So we came up with these metrics. The mean absolute error you would know. We also wanted to know these under prediction, over prediction, these two estimates. So if I made an estimate across C cities, in how many cities was I underestimating and how many cities was I overestimating the pollution compared to the ground truth? Now this we were specifically using because mean absolute error does not tell you the direction, positive or negative. We wanted to specifically look in how many cities were we under predicting and over predicting to understand the direction of the bias. We use these specific kinds of prompts. These are some examples. PM 2.5 concentration for the following location in year 2023. Again, there is a template to it. City, state, and then you have the same for a month level also. Okay, what do you think? Do LLMs understand plausible ranges of PM 2.5? Yes, no? This turned out to be true. So the plausible ranges generally are 0 to 500 microgram per meter cube. On certain days when the pollution is very high, the PM 2.5 can go up to 1000 microgram per meter cube, especially in North India. But here we're looking at the yearly or the monthly aggregate. So those numbers will be very rare. So all of the models were correctly able to figure out that nothing is below 0 microgram per meter cube and nothing is above 500 microgram per meter cube in the data set. That was correct. The second was we wanted to look at the concentration across different cities. So we tested across these different cities. Just a second. Yeah, let's first just look at this. So we have the predicted PM 2.5 on the y-axis and the actual PM 2.5 on the x-axis. And we're looking at these models. So this is a smaller Gemma, Llama 8 billion small model. And then these are the bigger models, Gemma 27 billion and Llama 70 billion. And you can see that the correlation coefficient is significantly higher for these two models. Although you can still see that the predictions are all over the place. In these first two models cases, you can see that they're actually playing very safe. We're almost predicting the same y value for any x value. For all the cities, they end up predicting similar. But at least for these bigger models, we can see that the correlations are higher. So it seems that even in the zero-shot setting, without having given any amount of training data or fine-tuned data, done any fine-tuning, it seems on average, the bigger models know something. How correct? We don't know. We can see that for the same x value, we have a lot of different y values. That is there. But on average, we still see that there is some positive correlation. Importantly, we wanted to now see whether they have an understanding of whether winters are more polluted than summers or not. So if we look at the prediction only, just look at the red bars. For Gemma and Llama 3.18 billion, you can see that the predictions across the months are roughly the same. So they're just predicting something like an average value. which means that they do not encode the notion of seasonality. Whereas if you look at bigger models, Gemma and Llama to a much greater extent, you can notice that they are very nicely able to capture the trends, the seasonal trends, which is important for us to now use. They do have a seasonal understanding. Then we want to look at the tier 3 cities. So we felt that the models will again favor bigger cities. They will say that only those cities are polluted. There are smaller cities, tier 2, tier 3 cities that will say they're not polluted. So we picked up some top tier 3 cities which we know are polluted from the ground truth. Most of them we end up under-predicting. So the LLMs end up under-predicting their PM 2.5 because probably they've not heard of them. Like how many have heard of all of these cities? Briniad, anyone heard? Begusara, I think 2-3 people at least said. Saharsa, anyone heard? Katihar, Purnia, like we have not, a lot of us coming from urban backgrounds might not have heard of these cities. So the LLMs also feel that these are perhaps not so polluted cities. So they end up under-predicting. Now, again, imagine that if someone were to fund based on an LLM search, they will say that these places are not polluted. They should not be given any money to fight the air pollution. So this is showing the underprediction. Actually, these are relatively lesser known cities, but they are still very polluted. That's the problem. That's why the LLMs are failing. Then we come on to the next question. So the hypothesis that many of us have is greener means less polluted. One way to measure greenness is what Dr. Bimal and Ujjwal showed in the morning, NDVI. They showed it with their Vedas tool. I am showing some static snapshot taken from the internet. So you can see that there is more greenness here. The NDVI is higher here, which is as expected. These are along the Himalayan foothills and the northeast is significantly greener. This is like a cold desert, this is like a hot desert, and this is also the Western Ghats. So we wanted to look at, so NDVI just tells you the normalized difference vegetation index. So as you mentioned, some ratio of the NIR and red. So we looked at this plot, predicted PM 2.5 and the average NDVI. This is prediction from our LLMs. And we see a reasonably strong negative correlation. So which means that LLMs to some extent are encoding that greener means less polluted. As per this diagram, we can perhaps conclude that it's not very significant. If it were below minus 0.6, we would have said it very significant, but still there seems to be some trend in this. Interestingly, if we look at the ground truth, so this was a way to think about this. So prediction versus the average NDVI, we see a negative correlation, whereas with the ground truth, actual PM 2.5 measured from the sensors and the average NDVI, the correlation is almost zero. So therefore, what it is indicating is that in the true phenomena, there is not a strong correlation between NDVI and pollution, but the LLM is somehow indicating that. So it's exhibiting some of the biases which sometimes we have, which some of the reports might have, but which is not data-backed bias. Then we also wanted to see that for well-known cities like Delhi, Mumbai, Bengaluru, Chandigarh, are the models under-predicting, over-predicting? They will end up over-predicting them because they feel these are the bigger cities, these are polluted, these are always in the news. There are models like, in this case, Gemma had a mean absolute error of 8.4, which is very low, which is very weird, or perhaps it has seen such data in the past. So you can see that the prediction is generally more than the ground truth. So the red bar is generally more than the yellow bar. For Gemma 27 billion, it's very close. So the prediction is significantly good for these cities for this specific model. So what we have seen is that smaller cities, tier 3 cities, etc., we will underpredict. Bigger cities, we will overpredict. We will see NDVI, more green means more pollution, less pollution. That's what we've seen thus far. We also wanted to see about the socioeconomic biases. So, do you think we will overpredict for, let's say, lower per capita cities with lower per capita, or overpredict? Underpredict again. So we will think that perhaps they are not going to be that polluted. So lower per capita perhaps means lower economic activity or lower movement, etc., lower mobility, etc. So therefore low pollution. Or maybe they don't even have the per capita information. So therefore you can again see that the red bars are generally lower than the blue bars, with the blue ones with the true values. In the states also, we saw some biases. So you can see that for some states, we will end up over-predicting, and for some, we will end up under-predicting. UP, we end up over-predicting. Bihar, we end up under-predicting across different models. So it seems that the bias is not specific to any particular model. It seems across multiple such models. We also tried a few variations of the prompting. So one is we just estimate the PM 2.5 for the city. The other is we give the city and state. The other is we also give some nearby cities. I leave this up to later discussions with the students. I will now finally just conclude that the larger LLMs, which we saw like Llama 3.3, 70 billion, they indeed show strong correlation with the ground truth. They're also able to capture the seasonal trends better. But across all the models, the lesser known cities, they're under-predicted. The more known cities are over-predicted. And then we also see a negative correlation, very reasonably strong negative correlation between PM 2.5 and NDVI, predicted PM 2.5 and NDVI, which means that the models are generally thinking that greener means cleaner. So overall, to summarize the two lines of work, in the first work, we were looking at structured data. We have the tabular data present. We will generate some Python code and we'll execute that Python code to get the answers. Second, we wanted to check what are the biases present in the data, present in the LLM's encoding of the knowledge. So we directly asked those questions and saw that there are indeed some important temporal biases, seasonal variations, spatial biases across states. We also saw the biases in terms of per capita income, etc. So all of this is indicating that currently systems, the LLMs are you should not be relying on them in the zero-shot setting, as well as they are very sensitive to prompts. Whereas for the first part, we saw that while there are some errors, syntactic errors, but those was also zero-shot structured data. If we were to do few shot, if we were to use specific code gen models, better code gen models, I think the first problem is very close to being solved better. So I'll stop here. I'll take questions on the second part or both parts. So since there are no questions, you can take a look at this. We will send the link over Slack and play with the tool BioBuddy. See if you can break the system and you can get it to work for some things. Like you were asking the questions, what happens if you were to ask a custom prompt? I think it will probably break. Let's see. I'm asking who is the PM of India. I hope that it doesn't give the answer. Yes, good. It doesn't give the answer. It shows that could not convert index error list out of range. Sorry? Okay. There seems to be some UI level problems. I don't know whether it ran. I think it ran the other question, but it's still giving the PM question here. But there are bugs, which means there are opportunities. People should solve it. It also leads to internships. Okay, so with that, I'll end and I can take questions offline, given that people are. And
How can we increase the power of each LLM? Because LLM are trained on like say but data is changing every day. So how can we incorporate the changes that is happening in the CPCB directly to the LLM?
yes, so how do we incorporate the changes? Let's say every day you get a new reading. How do you incorporate that new data to make better answers? So one way which we think is that this could happen via something known as tool call or function call. Let's say if CPCB were to expose their data through a structured API, I believe they do to some extent with some captchas, but let's say that the government bodies were to have an agreement and they were to give this to us via some, let's say under some agreement. So we could then with that specific API make this query and get the response and then give the answers. So that is tool call or function call. So currently if you saw, we are able to generate some Python code. In that case, the Python code which would be generated would be get more data and then it would be the parameters of that query. That's how you can keep that particular data updated, which is structured. For unstructured data, I think it's still hard. Like people are looking into RAG-like techniques. We were hoping not to get into that for unstructured data, but hoping more to understand the biases. Yes.
So for the custom prompts, like why will it not converting it to the and what benefits will it have rather than converting to that normal prompt?
I couldn't get the question.
So when you write a custom prompt, you were paraphrasing the prompt, right? So like you also had a prompt template like city and so like why were you paraphrasing rather than converting it to that prompt template?
Okay, so why did we paraphrase? So we had a particular slide where we were showing that the question which was being asked, so we had a template, we converted that into some other variants, as opposed to taking a user query and then fit into the templates, right? So if you were to take a user query, then you have to do template matching. Figure out which of the templates matches the question the closest and then extract out the parameters. That's one way you could have done. We didn't take that approach. That felt, again, you are trying to do either classification or trying to get a structured response from a LLM. We tried to keep it, let's say, to broader kinds of questions which the people can ask while creating. So we wanted to focus more on the data set and the benchmark as opposed to the LLM capabilities.
But the prompt template thing wouldn't give better outputs rather than the paraphrasing thing.
It may give, but that is the whole point. We are not going to show. So our purpose is not to say that we can get 99% accuracy, etc. It's to give a more realistic set of questions, including the templated questions, including some variants of those, to get a sense of what is the real world usage like, real world performance like.
Doesn't that, paraphrasing leads to a lot of more token generation consumption rather than just shifting it to the...
It did. I believe it would have done. I would leave all the paraphrasing questions to the students to answer after this. I think they can talk in much more detail.
Okay, thank you.
Okay, any other question? Okay, thank you then. We will see you in half an hour after this trip.